Hi everyone, my name is Gianmarco and today, together with my colleagues Corrado, Fabrizio and Riccardo, we will show you the steps for making this wonderful manipulator writing a letter on a sheet of paper. Now, before starting, let's have a brief recap on the components. So, this is a 5 volt 10 amps power supply for supplying the 5 servo motors of our manipulator. Then we have the Arduino board that supplies the digital PWM signal to the servo motors, and then we have the breadboard. So let's fire it up and let it reaches its starting pose. So turn on the power supply, connect the Arduino board to the laptop, and when it is ready, we can run the script. And this is its starting pose.
Exploiting the DH convention, we were able to model the robot in MATLAB environment and computed the corresponding parameters. Then, we planned the trajectory in order to write the letter A, and due to the nature of the task itself, such a trajectory was built in the operational space by means of segment based on the curvilinear abscissa. The result of this was a trajectory constituted by 7 segments, of which the first one used to reach the starting writing position of the letter A, while the other 3 segments are used to reach the starting position of the middle segment of the letter, and the remaining ones are used instead to write the letter itself. Unfortunately, the manipulator has 5 degrees of freedom, which is lower than the size of the task space, resulting in an underactuated manipulator. Therefore, this implies that there will be an uncontrolled rotation about an axis, and due to the nature of the task itself, it's strongly recommended that the pen remains in a vertical position throughout the motion. Therefore, the trajectory of the orientation was designed in such a way that the uncontrolled rotation will be about the axis of the pen, previously set in the vertical position.
Must take into account that the robot cannot attain all the possible poses in space. In fact, we have to consider the physical limitation that arises from the link lengths. The robot cannot go so far. In fact, it cannot reach every point in space, and it cannot be fully retracted, otherwise the joints will interact with each other. Another problem arises from the motor. In fact, the motor can span from 0 degree to 180 degree, and so it cannot reach every rotation.
Having defined the trajectory, it is necessary to address the fundamental concept of the inverse kinematics, which maps the operational space into the configurational one. The technique adopted for controlling the motion is the so-called kinematic control, suitable for controlling the manipulator motion with low acceleration and low velocities. This one can be a clever choice for our manipulator due to its slow pace in performing the task. The kinematic control can be implemented either in a closed loop or in an open loop configuration, where the former compensates for disturbances coming from numerical error due to the discrete domain, while the latter does not. At the beginning of our analysis, we ran some simulation using the open loop algorithm, and we observed that the discrepancies between the theoretical trajectory and the actual one was small enough to consider acceptable such strategies. In this way, good performances are guaranteed with a simpler topology.
Another problem that we have to analyze is the one related to the singularities of our robot. In fact, performing many simulations, we have seen that our robot has a singularity. To be more precisely, an elbow singularity that occurs when the arm is totally outstretched. In that case, in fact, we can see in the simulation that the joints underwent through a rapid switch in the configuration with high velocities. This is not a problem considering the simulation, but it would be a real big problem in the real life because it could be dangerous. Another problem that arises from these singularities is that the trajectory is completely changed. But This type of singularity is not a real problem because it is fixed considering the limitation we have set during the analysis on the workspace. So this is the only singularity we have in our robot, and there are no more singularity that could change it.